Okay, good morning. So let us start the lesson now. Today's lesson is actually simple, very simple, I would say. Let me start with this first slide. So that's a definition. So a group G and a star is said to be finite, a finite group. Very simple. If G is finite, if G is a finite set, otherwise it is called an infinite group. Yes. And then for a finite group, the number of elements, which we usually call the cardinality of the set G, is called the order of G and is denoted by something like absolute value, which is more common, but I prefer to use this OG for order. Okay? So if I have, so when I say that I have a group, can you see me? In case you cannot see me, can you? There are some places there if you want to get. Yeah, you can move it around if you like. Okay. So if I have a group, it means that I have a non-empty set equipped with a binary operation. Yes. If this G is finite, we say the group is finite. If this G is infinite, we say the group is infinite. In the case that G is finite, the order of the group, which I denoted by OG, and then of course in some books they denote it by absolute value of G for cardinality of G, is the number of elements in the group. Very simple, yes? Okay, so let us go to the next one. So for example, so far, you remember this was a group. Do you remember? We learned that this system, this algebraic system, is a group. Okay, and this one is an infinite group. Why? Because the embedding set, this set, is infinite. It contains infinitely many elements. But for example, on the next slide, I will show you. I don't know why this comes. So I don't know. Okay. So for example, let me consider this set -1 and 1 with just normal multiplication. This is also a group. Yes. Because normal multiplication is always associative, and then it doesn't matter, this is also closed. This set is closed under this operation. -1 times -1 is 1, which is inside the set. 1 times 1 is 1 inside the set. 1 times -1 is also inside the set. So it is also closed. Associative, it is closed, so it is a binary operation. It is associative because multiplication is associative. And what is the identity element? Of course, 1. 1 multiplied by any of these two, it becomes the same element. And what is the inverse of -1? Inverse of -1?
1.
The inverse of -1 is something that when is multiplied by -1 gives me the identity. The identity here, you told me, is 1. So what is the question mark here? -1. So usually from now on we write it like this. The inverse of an element is denoted like this. So the inverse of -1 is 1. So read it in the group theory way. Yes, because this is not a correct inequality if you read it in high school way. Yes, because in high school when you see -1, so if I have x, the inverse of x in group theory is denoted by x to the -1. It doesn't mean x1 over x. I'm talking about groups in general. So if you see something like this in group theory, that is not wrong, because it is telling you what is the inverse of -1. The inverse of -1 is that number which is multiplied by -1 and gives me the identity element. That number is -1. But if you give this to a high school student, they will calculate it like this, yes? Okay, so you should get used to this kind of notations. Okay, so I will talk a little bit about notation later. So, and then, so the inverse of -1 is 1. What is the inverse of 1? 1. So, yes, this is a group. And then it is a finite group. Why? Because my set contains only 2 elements. Okay, if I call this set G, then I would say that G and star multiplication is a finite group. Yes, and it is what? It's finite group, and the order of the group is, what is the order? 2. Yes, because there are two elements. Another one on the next slide I will show you. This is the other group. For example, let me take this minus 1, 1, I, and minus I in the set of complex numbers. Okay? And then again, I take the binary operation to be multiplication. So I am claiming this one is also a group. Okay? So let us check. First of all, do you agree that this is a binary operation here? I have to confirm that this set is closed under this operation. It means that no matter which pair you choose, if you do that operation, the result is a number within the set itself. Is that understandable? So it is very simple. Minus 1 times 1 is there. Minus 1 times minus I is there. So you can just convince yourself that this is closed. It is associative. Why? Because multiplication, even in the set of complex numbers, if you have learned this before, it's also associative. Okay? So is there any identity element here? What is the identity element? 1, because 1 multiplied by any one of them in both ways gives you the same element. And let us talk about this. What is the inverse of minus 1? Minus 1. What is the inverse of 1? 1. What is the inverse of I?
Minus I.
Minus I. Why? Because when I say what is the inverse of minus I, what is the inverse of I am asking you, can you give an element within this set so that when it is multiplied by I, gives you the identity element. So this means that I am looking for this question mark so that the answer becomes 1. So which one of these numbers fit that equation? Minus I. Do you agree? So minus I times I is 1. So, and then what is the inverse of minus I? I. So that's also a group. Is it a finite group or an infinite group? Of course it is finite, but what is the order? Order is 4. Is that clear? It's very simple, I think. So this means that I can skip this. So something is wrong. Okay. So that was the example I just talked about, but this is a very good example of finite groups. So I want you to pay more attention to this. Okay, and then I have given you two harder questions as checkpoints. You can do that later. But before doing this question, let me recap a little bit about some very important theorems from elementary number theory. Okay, so division algorithm, okay? Okay, so I just remind you what the theorem is. I really want you to remember the theorem, okay? So, and I want one particular case of this theorem that I will fix it for you. See, here, any one of you remember, have you heard about division algorithm in one of your courses? So if you have an integer, and if I give you b as another integer b, but I assume that b is not 0, then the division algorithm tells you that there exist unique integers q and r such that a is equal to bq plus r. Do you remember what is the next part? And r is greater than or equal to 0 less than absolute value of b. So this is the complete version of the division algorithm. So if you give me two integers, but the second integer is not 0, definitely there exists two unique integers q and r, so that a is equal to bq plus r. But the important thing that r is greater than or equal to 0 and less than absolute value of b. If you relax that condition, the uniqueness is gone. The existence will survive, but the uniqueness will go on. So if I want to make them unique, I have to restrict R between 0 and R. So this is claiming that this is correct. And in that case, do you remember what is Q called? I'm just trying to remember. The Q is the quotient of the division of A by B. So if you divide A by B, this Q is called the quotient, and this R is called the remainder of the division. And if you restrict yourself to this condition, Q and R are unique. So what does it mean? It means that if I give you two numbers and I ask you find the quotient and the remainder, everyone will get the same Q and the same R if they want to respect this condition. Okay? For example, if I give you A to be, I don't know, 21, and if I give you to be a 4, and if I ask you what is the remainder and the quotient of the division of 21 by 4, what do you say? You can immediately see that 21 is 4 times what? Times 5 plus 1. Is that right? But is this guaranteed that this number is the quotient and this number is the remainder? You have to check this condition. This number that you got, 1, is definitely less than absolute value of 4. And it is greater than or equal to 0. So this one is true. Okay? So I was able to write 24 in this form, and this number satisfies the condition I need. So then I can declare that 5 is the quotient of this division and 1 is the remainder. Yes? But for example, if I give you this, can you tell me what is the quotient and what is the remainder if I divide minus 21 by minus 4? Because here I need A and B be integers, not 0. Okay, so this means that I give you these numbers and I ask you what is the quotient and what is the remainder if I divide minus 21 by minus 4. So what is the answer? So I should write yes?
6 and 3.
Yeah, so let me, so 6 and 3. So you say that I would write minus 4 times 6 and then plus 3. Yes? Why the other way around doesn't work? So you see, if I write minus 21, I can write it minus 4 times 5. Yes? And then I have to write plus minus 1. This equality is still true, because minus 20 minus 1 is minus 21. But this number does not satisfy my condition. So by my definition, minus 1 cannot be considered as the remainder. So even though this equality is true, but it is not helpful if you want to find the remainder and the quotient. But this equality is not only true, because minus 4 times 6 is minus 24, plus 3 is minus 25. So it is true. On the other hand, this 3 is definitely greater than or equal to 0, and it is less than absolute value of minus 4. Yes? So this means that, yes, the quotient is 6 and the remainder is 3. Is that clear? Okay. But now one particular case of this is important for us. In this course, we usually have A to be a non-negative integer. So if A non-negative integer, yes, and then B belongs to n. In this course, I told you n starts from 1. So A is a non-negative integer, B belongs to n. If I want to rewrite this general theorem for this special case in which I am forcing A to be non-negative and I am forcing B to start from 1, okay, then what happens? There exist unique integers Q and R such that this holds. Yes, but this condition can be reduced to what? Instead of absolute value B, I just write B, because in this case B is positive. So I just write B. Yes? But one more thing is here is that Q should also be non-negative. In this case, Sometimes Q can be negative, but in this case Q is non-negative. Yes? So why Q is non-negative here? So my claim is, in this particular case, Q should be non-negative. So if not, what happens? If not, means that Q is less than zero. But I want to see that this is contradiction. If Q is less than 0, because Q belongs to Z, according to the division algorithm, so this means that Q is less than or equal to -1. Yes? And then I multiplied both sides of this inequality by B. Because B is positive, I don't have any problems. I just multiply by B. And then I add R to it. So this becomes BQ plus R is less than or equal to R minus B. But R minus B is negative. And this is my contradiction. Why? Because this is A. So if in this particular case, if I choose a non-negative A, integer A, and I choose a positive and natural number B, and I write the division algorithm, this is also guaranteed that this Q is non-negative. Because if Q is negative, I will have the contradiction that A is negative, but this is against my assumption. So this means that Q should be greater than or equal to 0. So whenever I use this symbol, it means I have a contradiction. Okay? So this means that I have to admit that Q is positive. So remember this very simple theorem. So A, non-negative integer. So let me, by the way, invent some notations for simplicity of writing. A belongs to Z, I put greater than or equal 0 on top. So by this notation, I mean A is a non-negative integer, and B is a natural number. And then remember this. So there exists unique non-negative integers Q and R such that A is equal to BQ plus R. R is less than B. I have already mentioned that R is non-negative, but let me also emphasize it here. So this is usually the one version of the division algorithm that we will need here. Any questions? Or when I write, can you see what I'm writing, or I'm still hindering you? Is it okay? More or less you can see? Okay. So now let us go a little bit forward. So if my question is that, is there any formula that I can write for the remainder? I give you A and B, and I want to give the remainder. I want you to give me a formula that I can use A and B to find the remainder. Okay? So how can I do that? So let me start from here. A is equal to BQ plus R. So what I do, I divide everything by B in this case. I'm talking about this case from now on. I divide everything by B. So this becomes Q, and this becomes R over B. Okay? So are you familiar with the floor function? So yes. So if two numbers are equal, the floor of this number should also be equal to the floor of this number. Yes? What is the floor? Let me just repeat it. So what is the floor of 2? The floor, yeah, it is 2 itself. But if I give you what is the floor of 2.5, you go to the left and pick the first integer. So what is the first integer? 2. If I give you what is the floor of minus 2.3, you go to the left and pick the first integer. What is that? Minus 3. So that's the floor function. Okay? So, but what type of number is Q? Q is a non-negative integer according to what we have. So the floor of a non-negative integer plus a fraction, I can flip this Q out. Do you agree? For example, if I have 1 plus 2.5, so let me write it like this. So what is the floor? Do you agree that I can write it as 1 plus the floor of this only? So if I have an integer plus or minus, I can write it as, okay, it's a little bit tricky if I have minus. So I can just take it out. In this case, this is positive. Because R is positive, B is positive, so R over B is positive. But can you tell me what is the floor of R over B? Yes?
It's always 0.
It's always 0. Yes, because R is strictly less than B. So when I divide R by B, it is, on the one hand, it is non-negative, but on the other hand, it is strictly less than 1. So this means that R over B, if here is 0, if here is 1, R over B lives somewhere here. And if I ask you what is the floor, if R over B is accidentally here, so the floor is also 0. But if it is not, it should be somewhere strictly between 0 and 1. Then I go to the left and pick the first integer, which is again 0. So anyway, this one is always 0. Understandable or not? Please interrupt me if you don't understand. Okay? Then what happens? This means I found the formula for Q. So Q is the floor of A over B. Is that right? Okay. Now that I have the quotient, I can find the remainder. The remainder from this is A minus B Q. Yes? But I already know Q in terms of A and B, so if I plug it there, so what do I get? So if I give you A and B, and I respect these two conditions, if I ask you what is the remainder, you can just write this formula. That's the remainder. And it depends only on A and B. It doesn't need anything else. Is that clear? Okay, now let us go to this question. This is one of the very important examples. So I will try to describe it precisely, but I want you somehow to send it to your memories. It's a very famous finite group, finite abelian group. So let n be a positive integer. Show that Zn, which is defined in this way, Z sub n is defined to be the set starting from 0, 1, 2, but up to n minus 1. And this operation, it is some kind of addition with some index n, is an abelian group. But what is this operation? It is defined in this problem. This operation B is the remainder of A plus B upon division by n for all A and B chosen from this set. And there is a name for this operation. This operation is called addition modulo n. Yes? So let me describe what it is. We want to show that this is an abelian group. Okay, so how should we do that? So let me write everything here. So Zn is the set of integers starting from 0, 1, 2, 3, but not up to n, up to 1 unit less. And then I am saying that for all A and B in this Z sub n, I am telling that this operation, this addition sub n, addition modulo n, is defined to be the remainder of A plus B by n. So I am writing it in as a sentence, yes? My claim is that this set, together with this binary operation, forms an abelian group. Okay, so I want you to help me to do that. What is the first thing I need to do? By the way, now, can you write a mathematical sentence instead of this English sentence for me now? So you see, instead of writing it in words, as it is mentioned in the problem, you're equipped with the formula there. So instead of writing it in English, if you don't mind, let me now write it in this way. But I want your help. Help me. Help me. The remainder of A plus B by n. Anyone else? Yes, John?
You just put in the formula, right?
You read it for me.
A minus B floor of A divided by B, right?
Not why A minus B?
Because that's what the remainder is, right?
This is the remainder of A by B. This is the remainder of A by B. This is the remainder of A plus B by N. So this means that A plus B plays the role of A, N plays the role of B. Understandable or not? Yes?
Because it's A plus B.
So it becomes A plus B minus N times A plus B over N. So we can write this formula in this form if you like. Or if you are more comfortable with this one, and if you are good in modular arithmetic, might be you can do it in a different way. I'm not saying this is the best way. By the way, I haven't seen any books doing it in this way. But I think it's easy to understand. Okay, so now I want you to help me. What is the first thing I want to do? I want to show that this is a group. The first thing is closure. I want to show it is closed because that's not obvious. Okay, you can use this formula, but you don't even need this formula here. Can you tell me why do you think that this set is closed under this operation? The remainder of any number by n. So what does it mean? It means that you divide A plus B by n. Yes, according to the division algorithm, there will be a quotient. There will be also a remainder. But this remainder has this property. It is between 0, including 0, up to where? Up to n, excluding n. So this means that this is between 0 and n minus 1. Do you agree? So you don't need even any formula here. Remainder of any positive number divided by n is minimally 0 and maximally n minus 1 by the division algorithm. So it is guaranteed by the division algorithm that this is closed under that operation. Okay, so that's the first thing. So the second thing, what is the second thing? The closure is established, but you have to write this if it is an exam, okay? So the second thing is associativity. So associativity, it means that I have to check this. I would say that for all A, B, and C in Zn, I want to convince myself that this is indeed the case. Yes? Okay. I will do one of them and then you can do the other one similarly. You can use division algorithm without any formulas, but I think for me it was easier to use the formula to do it. You can do it in any way you like. So I will start from here. I want to start from left-hand side. But please don't get confused and help me. And if I am making a mistake, please shout immediately, okay? So if I want to do the left-hand side, the priority is with this one. So I copy and paste this one for the time being. But I want you to tell me what I can write for this one in the pair of brackets. What does this mean? This means the remainder of B plus C over N. So I can use my formula here. This is the formula. So now A is played by B, B is played by C. So I put them in this formula. So what happens? It becomes B plus C minus N floor of B plus C over. Yes? Okay, so for not confusing you, if you don't mind, let me call this one R. Okay? And I want to go one step forward. So it is this operation with R. So A plays the role of A, R plays the role of B. So what happens? This becomes A plus R minus N, A plus R over N. Yes? Okay, now that everything is good, I put R back. You don't have to do this. I just want to make sure that you understand what I'm doing. So instead of R, I put this a little bit complicated expression. Yes, and then minus. It seems horrible, but it is doable. do you agree with me? There should be a pair of brackets here. So are you following? I'm just putting R back. Understandable? Yes? Not your heads.
I think you're missing,
Okay.
I think you're missing an n though in the top of the numerator, right?
Yes,
Which is the
yes.
n
Yeah.
multiplied
You
by
see,
the-
so don't nod your head. Okay, please help me. Okay, so that n should be there. Yes, you're right. Thank you very much. Okay, but this is very simple now. I don't need these pair of brackets because these are just normal addition and subtraction, so don't worry about the pair of brackets. So it becomes a plus b plus c minus n b plus c over n. Okay? And then let us do something in our head. Okay? So what happens if I open it up, a plus b plus c divided by n. So if you don't want, let me write. I have a minus n here. And then I have a plus b plus c over n. Yes? And then what happens, there is a minus n. When I divide it by n, n's are gone. I am left with this. Okay, happy? Not your head, but don't make mistakes, please. Is it correct? Yes? Okay. But now, can you help me to continue? What type of number is this number? Because of that floor, it's definitely an integer. And when I put a minus sign, even though it is probably a natural number or zero, but because of this minus sign, it might be an integer. But this is a formula it's good to know. If you have a floor of r plus any integer, so this becomes a floor of r plus z if z is an integer. Okay. This also works for minus sign. So what I do, I copy and paste the first part. I copy and paste this, a plus b plus c. I copy and paste this one. And then, according to this rule, this is an integer. Yeah, so this is definitely an integer. So I can pull this out by that formula. But there is a minus n here. So what happens, it becomes minus n, a plus b plus c over n. But when I pull this out with this negative sign, there is also a minus sign here. When I multiply, it becomes positive. Understandable? Yes? And then what happens? These two are gone, yes? And then I am left with a plus b plus c minus n, a plus b plus c over. So this is my left-hand side. I cannot go further. By the way, can you write this as a sentence, as an English sentence? What is this? You see, if you compare this with this formula, this is the remainder of a plus b plus c by n. Which was obvious, yes? Now, because I have three numbers, I want to add them, and I got this result. And it is very simple to do it again here. Very similar expression, you will get this exactly at the end. Okay, so that's up to you. So please do it for yourself. But is this understandable? So it is associative. What is the next step? Are you happy or not? Happy? Yes? I see some question marks on your heads. Please interrupt me, ask questions, okay? So, what happens now? I want to go to the next step. What is the next step? Checking if there is an identity there. But you have a guess for your identity. What is your guess here? You should have a little bit of guess. Do you remember yesterday I actually cheated a little bit in a scratch paper? I realized what should be this, and then I came back and proved it. So you should have some kind of intuition about your identity element here. But can you guess what is the identity element here? If you want to suspect one of them, which one?
Zero.
Zero. Yes? But let us check that. So I would say that we show that as 0 is the identity. So in order to show that, I have to show that for all A chosen from Zn, I have to show that this one is A. Yes? You can use the formula or can use a little bit intuition in number 3. If you write it in the exam in that way, that's okay. But because now we have a formula, let us use it, okay? So let us try to test this idea. A plus, I start from the, so let me check this one. A plus 0 is A. So I start from the left-hand side of this, okay? Left-hand side is A plus 0. I use my formula now. So it becomes A plus 0 minus n times A plus 0 over n. Yes? But A plus 0 is simply 0. Oh, sorry. A plus 0 is A. And I get this. But can I get rid of that floor part?
Yes.
Why?
Because
A belongs to Zn. Yes? So it means that A is one of these numbers. So it means A is maximally n minus 1. So when I divide that A by n, it becomes definitely a number greater than or equal to 0, but strictly less than 1. So if I have a number like this floor is 0. And then this becomes simply A. Yes, is that understandable? Okay. And then, of course, you can do it the other way around, okay? So that's very simple. So you can do it yourself. And then what's the final thing? So I want your intuition for the final step. For the final step, I have to convince you that any number that you pick from my list, it has an inverse. This is what I want to show. So what I want to show, I would say that let A belongs to Zn. We show that A has an inverse. In Zn. Yes? So what does it mean? It means that I have to convince you that there exists an A prime, for example, in Zn, such that A plus A prime is equal to A prime. A is equal to what? Yes?
0.
0. Why 0? Because in the previous step, the identity was proven to be 0. Okay? So you can put this in a scratch paper to understand what you want to do. So again, you have to have a little bit of guess. Okay? Because you will see that it matters. So let us do it a little bit like this. Instead of thinking about Zn, if the problem is hard, you go to a scratch paper, for example here. Let me write Z3. Let me make it Z4. So what is Z4? Z4 starts from 0, 1, 2, up to 3. Okay? But this time, I want to do what? I want to find the remainder by division by 4, because n is 4 in this case. So can you see in this problem, what is the inverse of 0? What is the inverse of 0? Inverse of 0 is a number within this set, so that when it is added to 0, its remainder by 4 becomes the identity, which is also 0. Yes? Yes? Okay. So what is that? What is the inverse of 0? 0 itself. Do you agree? Because 0 plus, let me write it like this. 0 is the remainder of this sum by 4. The remainder of this sum by 4 is 0, and 0 is the identity. So here, I hope that you agree, it doesn't matter if it is 4, 5, or n. So in this problem, the inverse of 0 is what? Is 0. Since 0 is 0. And of course the other way around. Yes?
Why do you write A prime, not A minus 1? After minus 1.
Yeah, technically I haven't introduced that yet.
Okay.
But you can write it. I'm writing it here. So you can. So in principle, I should write the inverse of 0 is equal to 0. Yeah, something like that. Okay. But now, can you tell me what is the inverse of 1? Just in the simple case. Can you give me one of these numbers in this list so that when it is added to 1 by this operation, it gives me 0? 3. Because 1 plus 3 is 4, and the remainder of 4 by 4 is? No, the remainder, the quotient is 1. The remainder is 0. So this means that, okay, the inverse of 1 is 3, because it neutralizes 1. So what is the inverse of 3? Of course, definitely 1. But what is the inverse of 2? 2 itself. Because 2 plus 2 is 4. Again, divided by 4, the remainder is 0. So you get an intuition how you should go. Because sometimes it is not easy to tackle the general problem. You have to consider special cases to get a feeling how to proceed. Yes, and then you do that. Okay, now this is done. But now I want your guess. So let A belongs to this. Claim the inverse. I want to hear from you. The inverse of A is equal to what?
N minus A.
N minus A. Yes, this is my claim. Yes. Okay, how should I prove that? I have to show that N minus N neutralizes A. Yes?
But don't we have a problem that if A is 0, then...
No, that's why I took 0 separately.
Okay,
So you are right. I have to mention that the inverse of, yeah, thank you very much. Because I considered a 0 itself separately, and now I am assuming that A is not 0, and I am claiming this, and I want to prove it. First of all, I have to guarantee that N minus A is within my set. Do you agree? Okay, is that the case?
Yes.
Yes, because A is already chosen from my set, so it is minimally it is not 0, it is minimally 1, because I am assuming that A is not 0, and maximally N minus 1. So N minus such a number will be again in my set. But you have to write these things in the exam. So the exam writing is my oral talking together with my writings on the board. If I want to write everything on the board, we will not be able to finish even one small chapter. Okay, but now I have to prove it now. So how should I prove it? I have to guarantee that this neutralizes A. Okay? So I want to show that this is equal to that one. Is equal to what? Equal to 0. But this is easy now. For example, I use again my formula. So A plus N minus A is equal to A plus N minus A. I am replacing B with N minus A this time. Minus N times A plus N minus A over N. So what happens now? This A and that A are cancelled. So this is N minus N. This A and that A are gone. N over N is just simply 1. Am I right? Yes. And the floor of 1 is 1. So it becomes simply N minus N, which is indeed 0. Okay, any questions? Yeah, we can have a break for 5 minutes because I have to clean the board as well. Thank you.